Hey, it's Mr. Luneski here. We are today looking at section 4 of Unit 10. We're looking at angles inside and outside of the circle, so it still kind of relates to what we were talking about in section 3. We have one more section after this. I think I may have lied to you in the last video, but one more section after this. Go up to 10.5. Alright, so let's take a look at this. Last section we looked at what do we do when the vertex is on the circle. Now we're going to look at what happens when the vertex is inside the circle, or what happens when the vertex is outside of the circle. So we had been looking at the equation arc equals 2 times the angle. And so that equation is going to change slightly depending on where our vertex is. So when the vertex is on, its arc equals 2 times the angle. When the vertex is inside of the circle, meaning the angle is created inside of the circle, we're going to do something called arc plus arc equals 2 times the angle. Essentially what that looks like here, so if we were solving for angle 1, this angle here, the two arcs that sort of are intercepting with angle 1, we have arc DC, and then if we sort of do our vertical angles here, we also have arc AB. And so we would say arc DC plus arc AB is equal to 2 times the measure of angle 1. And why we're multiplying by 2 is because we're sort of considering both of these angles here. Notice too that this doesn't have to be in the center, so kind of can't really read that here, it's a little blurry, but it says notice that angle 1 and angle 2 are not central angles, so they don't have to be in the center. So we can't really assume that. So in this particular problem here, if I were solving for x, I would say arc plus arc equals 2 times the angle being x. And so I would say that this is 120 equals 2x. Divide both sides by 2, and you would get that x is equal to 60. Down here, kind of have a little bit more of a challenge problem, a little bit more involved. So notice where the arcs are. The arcs are here and here. So my angle actually isn't provided, but I know that this angle, 128, and this angle here create a linear pair. And so to solve for that missing angle, I can do 180 minus 128, and I can get that this is 52 degrees. So the angle is 52. And so now when I go to solve for this, notice now I'm solving for an arc, so I'm still going to use my equation, arc plus arc equals 2 times the angle. The angle now being 52 degrees. And so when I multiply that out, I end up getting 104. And then I get x plus 34 equals 104. And so now for this to solve, we just do subtract 34 from both sides. And so when we do that, we get x equals 70. And so that would be the measure of this arc here. Okay. Whoops. Almost hit the wrong button. Alright. So that's if the vertex happens on the inside. Well, what if the vertex happens on the outside? Again, the vertex meaning where is the angle created? Well, instead of adding, now we're going to subtract. So if it's inside, we add. If it's outside, we subtract. So it's arc minus arc equals 2 times the angle. So in this example here, we have angle 1, and notice the arcs that it's intercepting. It's intercepting arc AC, and then it's also sort of intercepting this arc here, BC. And so we would say arc BC minus AC equals 2 times the measure of the angle. And so you always want to make sure you're doing the bigger arc first, and then the smaller arc. Otherwise, you end up getting negative numbers. So in this example here, if we were solving for angle X, again, arc minus arc, so the big arc minus the small arc is equal to 2 times the angle. 2 times x, so that gives me 70 equals 2x. Divide both sides by 2, we get x is equal to 35. There's another way that that can happen. So the example that we just looked at is what if it's a tangent and a secant line? There's another way that we can look at it is what if we have 2 tangent lines? Well, if we have 2 tangent lines here and here, notice what we end up doing. We end up intercepting the entire circle. So you always need to kind of have in the back of your mind that, well, 360 degrees is in a circle. So we're still doing arc minus arc equals 2 times the angle. So here, we're given the angle, we're given this piece of the arc, but now the question is, well, how do I find this piece here? How do I do that? Well, since we are intercepting the entire circle, we would have to do 360 minus 96. 360 minus 96 is 264. So now when I go to set this thing up, I'm going to do 264 minus 96 equals 2 times the angle. Arc minus arc equals 2 times the angle. And so when I subtract here, I get 168 is equal to 2x. And then when I divide both sides by 2, I get x is equal to 84 degrees. Alright, and last little scenario is, what if we have two secant lines? So we looked at a tangent and a secant, two tangents, and now two secants. So remember, a secant line crosses the circle at 2 points. So the same thing. Notice the arcs that are intercepted here and here. So we would say xy minus yz, or I'm sorry, xy minus wz is equal to 2 times the angle. So outside we are subtracting. So if I was solving for angle A, put a little x there if that helps you out. So we're saying 120 minus 40 equals 2 times the angle. When I subtract that out, I end up getting 80 equals 2x. Divide both sides by 2, and I get that x is equal to 40 degrees. Alright, the next two problems here are your try it questions, so try those out. In this one you are solving for arc zy, so put a little x there if that helps you. In this one you're solving for angle B, so we put a little x there. One more video after this. Make sure you are prepping yourself for the daily quiz. Thank you for watching. Have a wonderful day.